ahead.
Yeah. For Mr. Michael.
Remember. How can math be related?
No, I think I was.
Yeah, after recess.
Alrighty. Okay, that was pretty funny.
Love slap.
Okay, so we have these things called angle bisectors. You guys remember having segment bisectors?
Yes.
Okay, angle bisector. It's a ray that divides an angle into two congruent angles. So an angle bisector will be a ray, it has to be a ray, that divides an angle into two congruent angles. Yep, so you can put in the congruent symbol if you want to instead.
Is this an example or something?
Big brain. What?
Example?
It is an example. Yes. So, we have an example here. In this example, the big angle, angle BAD, or angle
BAB.
DAB. Okay. Angle or ray AC is the bisector, okay? So ray AC is the angle bisector. Therefore, angle CAB is congruent to what angle? Nope.
CAB is congruent to
CAD.
CAD.
Wait, we already.
No, BAC. No, yeah.
Okay, these two angles are congruent, so we could put tick marks in there, like the arches in there, the arcs in there. What's up, Saren? What? Yeah, what?
Nice.
What do you mean you have these?
You worked ahead.
You did work ahead.
You worked ahead,
Give
Sarah?
him, give him a new one.
What did you use to work ahead on?
I guess, and I'm pretty sure I got all of them.
You
right.
worked ahead.
All right, continuing on. Using an angle bisector up above. So the measure of angle CAB, angle CAB, would be equal to the measure of what angle?
Oh, B-A...
C-A-D.
CAD, or DAC, CAD, or DEC. You're not to use Dak Prescott.
Hey!
The overrated quarterback for the Cowboys. Anyway.
No longer my favorite
That's so
Mr.
true.
Fossil.
Oh, that's okay.
Who's gonna start?
Okay. Anyway, letter B. Measure of angle blank plus the measure of angle blank would equal the measure of angle dab. What do we think?
B-A-B and B-A-B.
Yeah, the two smaller angles are going to add up to be the big angle for angle dab. Okay. Now, could we also just double one of the angles?
Yeah.
Yeah. So we could double them because they're both half. Okay. You could say 2 times the measure of angle CAB is equal to the measure of angle dab. Okay. Or 2 times the measure of angle CAD, as in doggo.
Yeah.
Dab? Oh, I super did. Yeah, it actually wasn't that before, and I changed it this year actually just to make it that. Also, my pen is not working for me right now. There it is. There we go. Questions on that? Alrighty. So we're going to continue on to the next part here. Example 2. So we have ray AC, and it bisects angle dab. Solve for x and find the measure of angle dab. If angle cab has a measure of 2x plus 10, and angle DAC, DAC, has a measure of 3x minus 20. So we know AC is a bisector, so it cuts it in half, right? Okay, cuts it in half. Boop. Boop, those are congruent. So we know measure angle CAB is 2x plus 10. Let's label that. I like labeling. What else can we label? The other one is what?
Yeah, my phone.
And these angles are what? Congruent. Okay? So how could we find x and then the measure angle DAB, the big angle? Math. Okay, what math?
Combine the things.
Combine the things.
The algebra thing. Yeah, no.
Like
Equation has to equal.
Sorry, what, Sierra? They equal each other. Why do they equal each other, Sierra? They're congruent! When they're congruent, we should think side equal. Congruent, side equal. Congruent, side equal. Congruent, side equal. Okay, is that annoying yet?
No.
2x plus 10 equals 3x minus 20 They're equal to each other because they're congruent. The measures are equal.
How do we know it's a congruent?
Because we're told that AC, ray AC, is a bisector of angle DAB, so it cuts it in half. Yep. So we're told it bisects it. Yes. Okay, so now we start solving this. Okay, so we solve this equation. What would we do first to solve it? Okay, there's a couple different ways you can do it. Let's subtract 2x. Let's get our x's together. 10 equals x minus 20. Now what? Add 20 and x is 30. Are you guys okay if I don't write in that add 20? Okay, you don't have to write it in. Okay, we've been doing it up to this point because it's easiest. It's easiest. Excuse me. Ooh, that was bad. Okay, to write it just to show your work and for you guys to see what I'm doing. But if you know, I don't need to put it right. Okay, x is 30. That's half of what we're trying to find. What else do we need to do? What? Plug an x to where? Okay. So Kai is saying, don't you add both of them together and then plug an x? You could do that. Is that the same thing as plugging it into each separately and then adding them together? Yeah, or plugging it into one and doing what? Multiplying by 2, doubling it. Okay, you can do any of these options. Okay, so I'm going to practice by plugging it into each, so just to check our work. So 2x plus 10, 2 times 30 plus 10. So 60 plus 10. So that's 70. And the other one, 3x minus 20. 3 times 30 minus 20. So 90 minus 20. So that's 70 as well. So are they equal?
Yes.
The measure? So they are. That's good. We did something right. Okay. So what's the measure of angle DAB? 140 degrees. Very good. Add them together.
Put 170.
I just put 170, didn't I?
Yes, you did.
That's what I call a botch. Okay. I know. Botch? All right. Question on this one. Okay, so we use an angle bisector there. We weren't told they were congruent, but we were told it was bisected, which means they are congruent, okay? See how we just took one step more onto that? Okay, Dank, Dope, and Liddy. Another one, very similar. Ray AC bisects angle DAB. Solve and find for x and angle DAB. This time, what are we given, though? We're not given CAD. What are we given instead? DAB. Okay. So we can still fill in what we know, right? What's something that we know? Okay. That angle CAB is CAB is x plus 5. What else do we know? Okay, the whole thing is 4x minus 12. What else do we know?
Dad minus cab equals CAD.
Okay. So that would be true. But can we set up the equation like that because we don't know what CAD is?
Probably not.
No, we got 2 variables. That will work.
Well, but it says solve for x and find DAB.
Okay.
You know what DAB is.
Okay. But we don't know in numbers, do we?
Oh.
Like a certain number of degrees. Okay. Great question. Okay.
Isn't it the same as the other one?
Not the same. Why is it not the same as the other one? Okay, Bill.
Well, I was gonna say, it could be like a multiplication, or not multiplication, like adding like 2 plus 2 is 4, so like 4 minus 2 is 2. You just use that to get it.
Okay, so explain how we would use that.
Well, you just like, I don't know, kind of like reverse it, like 4x minus 12, but instead of like equaling, we add something like minus it. Something.
Okay. Let's see if Max has an idea on top of yours.
You divide like the equation for DAB by 2, so then it would be 2x minus 6 would then equal 5, x
Okay.
plus 5.
Okay, so if we take half of DAB, that would equal the what CAB would be, right? Because it should be half because it's bisected. Okay. Could we also double angle CAB?
Yeah.
Yeah. Now, will we always be able to easily divide something by 2?
No.
Maybe not, but on this one we could. Okay. So we could definitely do that. 4x minus 12 and divide by 2 and get 2x minus 6 and set that equal to x plus 5. Or you could also do, and we'll probably get more used to this way, 2 times x plus 5 and set that equal to 4x minus 12.
What?
Oh.
I thought we were doing that in the first place.
Okay? Any questions on why that setup works? Either of them.
No, but can I solve it?
Okay? You're confused on the blue one.
X equals
Okay?
5?
So x plus 5 is this, right? Now this should be half of the whole big angle because it's bisected. So if I double half of it, should I get the whole thing? So I'm going to double half of it and get the whole thing.
Why do you need the parentheses?
Because you need to make sure that you're multiplying 2 to the x and to the 5. Because x plus 5 is the whole angle. So you don't just want to double x or 5, you have to double the whole thing. So you have to make sure you distribute to get 2x plus 10. Go ahead and keep solving this, and I want you guys, once you have it or have questions, to raise your hand. Once you have it or have questions, to raise your hand. Jacob, do you want to help me, people? Okay, cool. Thank you. If you want to keep working on your homework, you can. That's all right. So here's what x is equal to. Here's the angle. So in the blue, I'll do this one first, then I'll go through and do the orange, okay? So in the blue, we continue solving this. You subtract 2x, subtract 2x. 10 is equal to 2x minus 12. Add 12. 22 is equal to 2x. Divide both sides by 2. Have you guys ever seen that? The little division I did where I divided both sides at the same time? It saved me writing a little bit, but it means the same thing when you're dividing both sides of the equation. Okay? So 11 is equal to x. Okay? If I do the orange, I'm going to get the same thing though. Okay? Subtract x. 5 is equal to x minus 6. Add 6. 11 is equal to x. Okay? And also in my blue, could I have done a different first step besides distribute? Yeah, I could have divided by 2. Because the entire side's being multiplied by 2. Okay? So I could have divided by 2 and gotten the same startup as the orange, right? Okay? That's how you know the equations are equivalent or the same thing. Then we have to plug it back in. Where did you guys plug this back in at?
CAB.
In a CAB? Okay? You plugged it into DAB? What would be the advantage of plugging it into DAB over CAB?
Easier, faster.
Because that's what you're trying to find, right? Okay? So you can plug it into CAB and still get it right. 11 plus 5, that's 16. Double it, get 32. Or you can plug it in here. 4 times 11 is 44 minus 12. And you know the measure of angle DAB, the whole thing, is 32 degrees. So the grand scheme of things, does it really matter which one you plugged it into? No. Okay? But if you can work smarter rather than harder, why not? Okay? Aiden, what's up?
Why is it obtuse but it's still 32 degrees?
Ah, great question. What? So did I tell you guys how about things won't always be exactly what they look like? One of those. ACT will do stuff like this.
Only
Yep. Jacob, have you taken the ACT?
Yeah,
Yeah. Would the ACT do something like this?
definitely.
Yep. They're tricky.
Like the first 20 questions for sure.
Yeah. Yeah. They like to get you on them. Like, oh, this is easy, but we're going to mess with your mind. So that's what they do.
understand it's like 30 minutes.
I don't know. That
Yeah.
should be like illegal. They shouldn't be able to do that.
You want?
Just be able to have
That looks like it
show.
wasn't 90 degrees, why is it?
Yeah. Yeah. And I love that you're thinking rationally about it and being like, that looks more than
It's
32.
an obtuse angle.
Yeah.
That's what it looks like.
I know me and Max thought the same score.
Yeah.
It looks like one, but clearly it's not because it's 32.
I didn't study either, I just took it.
Why couldn't they
Me
at
too.
least try?
All right, let's talk about adjacent angles. Anyone know what adjacent means?
I forget because
Nope.
touching.
They're next to each other. Adjacent means they're next to each other. They're touching, okay? They're touching or they're next to each other, okay? Kelly, put it away. Okay. So, they have a common or shared side. Adjacent angles have to have a common or shared side. They have to share a side, okay? So like here, we have two angles. We have angle A and angle B. Okay, right here, A and B, okay? They have a shared side down the middle, that ray in the middle, it's shared. They also have a common vertex, so their starting point has to be the same. Common vertex.
Doesn't that mean it was bisectors? The way you see it?
So, great question. They would be bisectors, okay? Not necessarily, but when an angle is bisected, then they're adjacent. But it doesn't have to necessarily cut it in half. Let's look at this here.
So it's just a more non-specific bisection.
Not quite. So let's look at this. This little drawing I did up there. Those two angles here, I'm talking about this angle and this angle there, those are adjacent. They have a common side right here in the middle.
Yep.
And they have a common vertex in the green. But they are not bisected because we don't have any markings saying that they are.
Oh, okay.
So they can be adjacent without being bisected, but they can't be bisected without being adjacent. Because for them to be bisected, they have to be next to each other, have the common vertex and common side.
So adjacent angles is more correct.
Yes.
But bisected is under.
Yeah,
Okay.
that's a good way to think of it. Aiden.
What's an example of them sharing a side but not sharing the same vertex?
I don't think they're part of it.
Let me think of that. That's a great question.
Triangles like this.
Yeah. You wouldn't get same.
Yeah, but the side is of the ray, so it'd have to have the same initial point, same direction. I don't know if there is one. That's a great point.
So it's just
It's-
shares a common side.
It's technically redundant, yeah.
Well, unless you
Big
never
brain.
Yeah.
I
Yeah,
think that-
that is a big brain. I hadn't thought of that. Vertical angles. Talking about vertical angles, okay? So we're not just saying vertical like up and down like a vertical jump. Vertical angles is a different classification, okay? So vertical angles, they're a special type of angle relationship, okay? So vertical angles, they share a vertex. They share a vertex. In this case, they would share the vertex point E. Okay? Their sides will make two straight lines. They're across from each other. So they're not next to each other, they're across from each other. So they are not adjacent. And they are always, all caps, congruent. Always congruent, always have the same measure, 100% of the time. So if they fit the first three categories, they're always congruent. Let's look at this example here, though, before we flip the page, okay? So in red here, angle FEI and angle GEH are vertical angles. They share the vertex E. They share a vertex E there, okay? They also, their sides make two straight lines. If you look at side EF and side EH, do they make a straight line? Yeah. Side EI and side EG make a straight line. And they're across from each other. They're not right next to each other. They're across. They're opposite. So they have to be congruent. They're both 46. Okay? Another way I like to talk about this is they make an X. Write that down, please. They make an X. Do those two angles kind of look like they make an X together? If you look at the sides. The sides kind of look like they're making an X. Okay? Kind of like you're throwing the bones. Okay?
Then doesn't that mean that angle IEH and are also vertical?
Great. So these are also vertical angles right here, as Kaya said. Angle IEH and GEF are also vertical angles.
Please come to the office after the bell.
Oh my god, poor Natalia. Poor Natalia. They just said Natalia.
Natalia.
Yeah.
They
But-
never said the name right.
Yeah. Well, anyway. All right. So there's two sets of vertical angles here, though, aren't there? Okay. Kaya pointed that out. Any questions on these on vertical angles? All right. We're going to use these vertical angles as well to help us find measurements, just like we did with angle bisectors.
Sam Campen, please come to the office after the bell.
Why do they keep calling me?
They did that lot.
Office, are they texting us?
Mm.
Poor Donald.
They're really overestimating the abilities of high schoolers' memories.
Right. Okay. Anyway, Aiden.
But it says find next, so I found it.
Anyway, so on this example here, do these look like vertical angles?
Yes.
How could we know?
Because it makes that. Yeah.
They make an X. They share the vertex. They're opposite each other, and their sides are two straight lines. They make an X. So what can you do with these vertical angles? They are always congruent. So what do you know about things that are congruent?
The same.
They're the same. So what can you do with their measures?
They equal each other.
They equal each other. Set them equal and find X. When you have it or have questions, raise your hand. Talking about this one. So set them equal.
Cross on 3.
3x plus 20 equals 10x minus 15. Subtract 3x. Put our x's together. 20 is equal to 7x minus 15. Bill to you.
Short. I am Big Willie style.
Bill.
X is 5.
Bill.
Does it matter that I have 5 equals X versus X equals 5? Heck no, it's the same thing.
Little bits of matter.
That's a property we're going to learn later. You'll love that one. Okay, any question on this? Continuing on. Linear pairs of angles. Linear pairs of angles. Linear, what word do we see inside of linear?
Line.
Line, okay? Pairs, how many things?
2.
2, okay? 2 things, 2 angles that make a line. 2 angles that make a line, okay? So they must be adjacent. We learned about adjacent just a bit ago. They must be adjacent. And they must be supplementary. What does supplementary mean? Great question. Supplementary, as you can see this little like sub-bullet, okay? It means they add, okay, to 180 degrees.
Why is there so many letters? Oh, it's because I kept it going.
What?
Yes. I kept on writing.
Okay? So they have to be adjacent, they have to be next to each other, and they have to add up to 180, aka be supplementary. That's the word we're going to use a lot, supplementary. Okay, think of like supplementing. You're adding to it. It's being supplemented. Okay. Or you might have heard of like nutrition supplements. Have you guys ever heard that? Like on the doctor's office, like, are you taking any supplements? Okay, things to add to your diet. Okay. So here, on example 5, okay, we're supposed to find x. So this would be a linear pair. These angles are adjacent. They share the vertex and the side, and they make a straight line. They're supplementary. They add to 180. So did we have a problem like this before, though?
Yes.
Yeah, we totally did. Okay, let's do this together real quick. 8x minus 16, and what operation are we going to do? Add. Very good. 5x plus 1 equals 180. Does that make sense? Any questions on how we set that up? All right, I'll trust the algebra skills. Okay, 13x minus 15 equals 180. 13x equals 195 if we add 15, divided by 13. X is equal to 15. We don't have to do anything else, we just have to find x. Questions on that one? If you didn't read it, did you do extra work? Yeah, there is an advantage to reading it. We can also check your work that way. But we didn't have to go any farther, we just have to find x. Questions on that one? Alrighty, okay. Okay, so we have 3 different things we've learned about so far. We've learned about linear pairs, we've learned about vertical angles, and we've learned about adjacent angles as well. But we're going to talk about vertical angles, linear pairs, or neither. So we have these 5 different angles, 1, 2, 3, 4, and 5, okay? And so we're going to say, given the pair, so letter A, angles 4 and 5, are they a linear pair, vertical angles, or neither? What would you guys say? They would be a linear pair. Can you explain why they're a linear pair? Okay, they add up to 180, so it's supplementary. They make a straight line, hence linear. What else do we know? They're adjacent, aren't they? They add up to 180, and they're adjacent, so they have to be a linear pair. It makes a straight line, okay? I want you guys to do B, C, and D on your own. B, C, and D on your own. B, okay? Angles 4 and 3, what would we call those? Vertical angles, I agree, okay? Their sides do make that perfect X there. That's probably going to be our easiest way to think about that, okay? Bill?
Did you put B dot A dot?
No, but thank you for asking. Okay? I would be okay with shortening it to vert, V-E-R-T, though. Okay? Angles 2 and 4, what could we call those? Neither. They are not adjacent, so they can't be a linear pair. Okay, because angle 1's between them. And they're not vertical angles, because they're not directly opposite each other. Okay? 1 and 5. Bill? Okay. Are they vertical? So do their sides make an X?
Not really.
This part they do, but here do they? Nope. So they're neither. There's not linear pair either. Tricky, 2 neithers. Okay. Good luck. Just so you know, on your pass it says you're going to restroom. It says you're going to Costal.
Oh.
But keep going.
Actually.
Okay, let's talk about complementary angles. This is something we haven't learned yet about complementary angles. So what do we know about all complementary angles? We haven't learned it yet. But they add to not 180 degrees, but to 90 degrees. Complement is less than supplement, okay? Complement is adding to 90, okay? So a picture of these, you get any two angles adding to 90 degrees, kind of like in our warm-up earlier, right? So complementary, if two angles are complementary, okay, it means they add up to 90 degrees, okay? I like this poster over here right behind Aiden, okay? There's two complementary angles. Angle B and angle A are complementary angles. Angle B says, I like that you're a good friend. Angle A says, I like the way you always help me. Get it? They're complementing each other because they're complementary angles. Okay, it's like probably my favorite poster in here because it's so cheesy and bad. Okay? Anyway, what do we know about all supplementary angles? We said earlier they add to 180 degrees.
And then you can just
Okay, so that could be a picture. Those two angles add to 180 degrees. Liam, what happened to your desk, buddy?
Fell too strong.
Makes sense.
My gravity's been weird here.
All right, continuing on. We're going to do a couple examples here. So on this example, 2x plus 15 and 3x minus 5. Find the missing values and angles. Name the angle pair relationship we use. It might be helpful to do that last part first. What kind of angle pair relationship do we have?
Supplementary.
Supplementary, and they are a linear pair. So they add to 180, right? And they are supplementary because they're a linear pair. So what equation could we do here? Dominic, can you help me out here? What equation would we do here?
Two x plus 15 plus 3x minus 5 equals 180.
Very good. Add them together to equal 180 because they're supplementary. Okay. Question on how we got that equation. Awesome. We combine these like terms. 5x plus 10 equals 180. 5x equal to 170. And x is 34. Then we're also asked to find the other angles, the two angles, ABD and CBD, by plugging it in. Or ABD, excuse me. I didn't add the points in though. A, B, D, and then CBD. Okay, I added them in now. The light blue corresponds to the light blue on the slide, and the green corresponds to the green. But if you're colorblind or if you're looking at the paper, it doesn't really help, does it? Okay.
Colorblind?
No, I said if you are.
Oh.
I'm colorblind.
I just told you what colors they were.
Oh.
But
Well,
Maybe said
that's what.
Well-
Like, if people are colorblind their whole life,
Yeah,
when they
they're
say and if they see red as orange, they're just gonna call orange red.
yeah, I guess.
So you could just be seeing something different and be calling it thing, and you have no idea.
Yeah, that's true. It's true. That's true. How awkward. All right, so we can plug it back in. 34, plug it back in. So you could have 68 plus 15, 83 degrees. And the other one should be adding up to 180, so it should be 97. Let's double check. Okay, so we have 34 times 3, so 102, minus 5, so 97.
I still don't think they know how to draw lines.
Okay, questions on that? That looks like a straight line.
Yeah, but it should be, both of them should be like close to,
Oh.
90 degrees.
Oh, yeah.
That's gonna confuse you.
I know, but it's dumb.
All right, any other question on this one?
That's the
All right, let's go. I want you to try example B. Let me try example B here. Yeah.
Oh, no.
Good luck. Raise your hand if you know the angle relationship we're going to use on one of these. There's two different angle relationships you have to use. Vertical angles to find which angle?
B.
B. Vertical angles for B. Okay, so what's the measure of angle B?
Supplementary.
26 is the measure of angle B. They're congruent because vertical angles are congruent. Okay, what relationship would we use to find another angle?
Supplementary.
Okay, supplementary, linear pair. Okay. On which angle?
A and B.
A and C. So they're congruent because those are also going to be vertical angles with each other, won't they? Okay. How could we figure out the measure then? Bill?
This is definitely not related. Have you heard anything about SEA yet?
No, I have not. Yeah. It is not related though. Great question. Kaya?
180 minus
Yeah, 180 minus 26, and that would be what?
100.
154. Okay. Any questions on this one? Okay. We're going to skip the next example. Oh, we're going to skip the next two examples. I don't have them on here. Okay.